Good afternoon. I am Giorgio Pennazza. I am the responsible of the unit of electronics for sensor system. And this work is a joint venture, the result of a joint venture between two labs, my lab and the lab for biomedical robotics and biomicrosystem. And I am in charge mainly of the sensor part. The talk reflects, it can be divided into three parts, which reflect the title of the talk, because I will present you the liquid sensor with the setup, calibration, and application to drinkable water. And then the idea of a network enabled by biorobotic technologies. And finally, the bio-inspired robotic fish, with its mechanism and actuation, obstacle avoidance system, currentiform propulsion, and pitch control. The setup is made up of an electronics of control with an operational amplifier and three electrodes with a working electrode made of gold, a counter electrode of platinum, and a reference electrode of silver, which is stabilized electronically. And the input is a triangular waveform with from -1 volt to 1 volt at a frequency of 10 millihertz. And the sample, with 1 sample per second, the output is a 100 sample array, which is like you have a virtual array sensor of 100 sensors, because we treat these outputs as multidimensional data. So this is an example of the calibration with some standards, ethanol, hexane, and isopropanol, and holy water. And you can see here the construction of the fingerprint of each of these samples using the output and input values. And using building a model, a PCA model, principal component analysis model on this fingerprint, we can obtain a sharp distinction of the different samples. And we also calibrated the system to different concentration of these three standards with PLS, partial least square analysis. And you can see there, not so clear, but anyway, you can see different clusters because it's the score plot. But here you can see the prediction of the concentration of each standard in the water sample. And finally, coming to the application to drinkable water, we measured many different Italian water. And you can see here that we obtain different profile of the fingerprints for example, three different water that I think that's in Italy are very famous, and you can see that are obviously different in the profile, in the shape of this fingerprint. But we also calibrate, we also built a model on this multidimensional data in order to predict, to estimate the content of some salt and some physicochemical parameters. For example, you can see here a model for dry residue, electrical conductivity, bicarbonates, potassium, and so on. And I have to say that considering that the label of the water bottle it's due to the analysis that they periodically repeat in some lab, in some university, every 2, 3, 4 years. The root mean square error in validation of this calibration system is also due to the fact that probably the parameters indicated on the lab are not the same of the water sample we have measured. And this is a PCA score plot reporting a discrimination of all the I don't remember, 12 or 13 different water we measured, and you can see a very clear distinction between oligomineral and mineral water. So we thought that with our colleagues, because the collaboration is very easy, because we are two different labs in the same very large room. So we meet every day, and we say, okay, you have the fish, we have the sensor for liquid, we can do something together, which could be very interesting. So analyzing a large volume of water without using a large number of network sensor nodes, for example, our sensors, can be done if you have a biomorphic robots, and they have designed something like an artificial fish. And anyway, we are not so original, because I think every one of you knows this European project, Shoal, and they publish in Talanta about electrochemical microsystems, which are very similar to our sensors, and they also foresee to mount these sensors on an artificial fish they realize in England. But anyway, we are working on this, and if we are two, probably the idea is not so stupid. So this is a biorobotic fish. This is the real one. It really exists, and the main points are the horizontal motion inspired by carangiform propulsion of fishes, like the carps, and the obstacle avoidance system is inspired to dolphin sonar system, and pitch controlled by a center of mass displacement, which is controlled by a pressure sensor. This is an overview of mechanics and actuation, and I show you mainly because you can see that there is also some space inside the fish, so we can also put it inside a lab, I don't know. And this is an overview of the obstacle avoidance module hardware. You can see in the